Okay, now we will be starting the today's lecture regarding the chemical bonding. In that we will be having today's discussion regarding the chemical bonding, how regarding the overlapping and hybridizations. Regarding the sigma bond and the pi bond, we will be having the discussion, and after that we will be entering into the concept of hybridization. So first, what is overlapping? So generally overlapping will occurs between half-filled orbitals. Okay, overlapping occurs only with the half-filled valency electrons. Okay, so that is most important point is overlapping occurs between half-filled valency shell orbitals of two atoms. Okay, overlapping occurs only between the half-filled valency shell of orbitals of two atoms only. Okay, that is the thing. And orbitals will come close to each other from the direction in which there is a maximum overlapping. Okay, orbitals will come close to each other from the direction in which there is a maximum overlapping. Already we had a discussion that ionic bond is a non-directional bond, whereas covalent bond is a directional bond. And the extent of overlapping is directly proportional to the strength of bond and is also directly proportional to the direction of the bonding. That is, it is based upon the hybridization, and extent of overlapping is inversely proportional to its is inversely related to its size. Okay, when you compare SS overlap between the 1s orbitals of S and 2s orbitals of S and the 3s orbitals of S, the least overlapping is done in the case of 3s. High overlapping is done in the case of 1s orbital. Okay, so overlapping occurs between half-filled valency shell orbitals of two atoms. Orbitals come closer. Orbitals come closer to each other from the direction in which there is maximum overlapping. Okay, in which there is maximum overlapping. Next, covalent bond has directional character. And the extent of overlapping is directly proportional to the strength of bond. And the extent of overlapping is directly proportional to the directional character. This directional character is on hybridization. It depends upon hybridization. So SS hybrid orbitals. Okay, I can write like this: hybrid orbitals are greater than SS and PP. So first PP and greater than PSS. So this is about the extent of overlapping. So after writing this, I will show you how the overlapping will be. You may be getting in your mind actually what is overlapping. So we will draw how the sigma bonds and pi bonds will be formed. Then you will be getting about the clarity regarding this all. And extent of overlapping is inversely related to its size also. Is inversely related to its size. Okay. Suppose if 1s is there, it is greater than 2s, is greater than 3s. So it depends upon the size of the overlapping. Okay. After you note down these points, then we will exactly give you what is overlapping. Okay. So you can note down this clearly. Overlapping occurs between half-filled valency shelled orbitals of two atoms. Okay, orbitals come closer to each other from direction in which there is maximum overlapping, and covalent bond has directional character, and the extent of overlapping is directly proportional to the strength of the bond and is also directly proportional to the directional character, that is hybrid orbitals greater than pp orbital greater than ss orbital, and the extent of overlapping is inversely related to the size. Okay, it is inversely related to the size. It is inversely related to the size. Okay. So hope you have noted. Okay, now we will be discussing about the overlapping. So generally then we have two types of bonds, sigma bond. This is sigma bond and another one is pi bond. So in covalent molecules, two types of bonds are formed by the orbital overlap. Okay, suppose let us consider s orbital, one s orbital and another s orbital. So like this they are overlapping, that is through the internuclear axis they are overlapping. So what happens, the shape you can see clearly, it will be like this. Is it or not? So this is called sigma bond when it is through the internuclear axis. See, this is the p orbital. So what happens, these will overlap. How the shape will be means like this. This is the shape. So when one s orbital and one p orbital, sp, okay, this is the overlap, sp orbital. So sigma bond means, see, the overlap is through the internuclear axis only. Okay, the overlapping of the orbital will be through the internuclear axis. So it is called as the sigma bond. Okay, the overlapping is through the internuclear axis. Okay, so that is called as the sigma bond. Okay, sigma bonds, we call them as sigma bonds, which along with their axis position, that is called as the sigma bonding. Okay, now what is the pi bond? So what is a pi bond means, it is through internuclear axis. Sigma bond is through internuclear axis, whereas the pi bond, what will happen, it will be through the lateral surfaces. Is it or not? So it is formed by the side to side or lateral surface. How it is means you see now. The pi bonding. How the pi bonding will be. Let us consider this is the peak orbital. So they will overlap. Okay, like this, side to side. Okay. In when it comes, we will show like this the overlap. See, this is what through internuclear as a sigma bond, and this is to side, like this they will overlap side to side, that is pi bond. Means whenever a pi bond is formed means definitely there will be one sigma bond. That is the most important thing. Okay, and the another point is what, suppose if double bond is formed, definitely one will be sigma and the other will be pi. Suppose if it is a triple bond, one sigma and two pi bonds. Or it can be all the sigma bonds also, all the pi. But pi bond is there means definitely there will be one sigma bond. That is the case. After the formation of sigma bond only, pi bond formation will take place. Okay, so just I will give you points regarding the sigma and the pi bond. Okay, so sigma bond. Sigma bond is a type of covalent bond. Formed by end to end overlap. End to end overlap of bonding orbitals. Along the internuclear axis. This overlap is known as head-on overlap or axial overlap. Okay, head-on overlap or axial, through the axis it is coming, no? So that's why it is called as that. Okay, overlapping of two hybrid orbitals always result in sigma bond only. This is important point. Overlap of two hybrid orbitals. Result in the formation of sigma bond. Okay, in the formation of sigma bond. Next, what is a pi bond? Just now I said pi bond is a type of covalent bond formed by the side to side overlap of bonding the orbitals along the coaxial surface. Okay, coaxial axis. Okay, pi bond of covalent bond is formed by the sidewise or lateral overlapping of half-filled atomic orbitals bonding atoms. And pi bond is always formed only after the formation of sigma bond. So pi bond is always accompanied by formation of sigma bond. And what is the major important point is pi bond formation will shortens the bond distance. That is why single bond will have more distance than double bond, and double bond will have more distance than triple bond. So formation of a pi bond will shortens the distance of between the atoms involved in the bond formation. Okay, formation of a pi bond shortens the distance between the two atoms involved in bond formation. So that is why CC is greater than C, double bond C is greater than C, triple bond C, bond length. Okay, so these are the important points. Sigma bond and pi bond overlapping, we call them. Okay, if they are overlapped like this through the internuclear axis and through that means it is okay. You can note down. Okay. Diagram if you want, already in the starting only I have gone. Still once again. I will show you both the sigma and pi bonds how it will be. So here what is happening in this bond is sigma bond, and this sidewise this is pi bond. But don't write it down. Any one you have to consider. Okay. So that is sigma bond and pi bond. Okay. So that is the way you will be representing. And now the next topic, which is most important for JEE and NEET competitive exams, hybridization. Okay, regarding hybridization we will have the discussion now. We are going to have the discussion is regarding hybridization. Okay, so generally hybridization, it is introduced by Pauling. Pauling has introduced this hybridization. Who introduced this means Pauling, to explain the equivalent nature of the covalent bonds in a molecule. Pauling to explain the equivalent nature. Okay, to explain the equivalent nature of covalent bonds. Present in a molecule. Okay, to explain about the equivalent nature, he has proposed this. Who proposed hybridization concept means Pauling. It is nothing but mixing of orbitals of different shapes and of approximate equal energies. Okay, approximate equal energies. For this, I will give you one example to you. Suppose if you consider carbon atomic number 6, 1s2, 2s2, 2p2. Okay. Now you see in for 1s you have 2 electrons, and in 2s you have 2 electrons, and in 2p you have only this. So now what happens you see here is px, py and pz. No? So this one electron jumps, all are of equal energy. Okay, so that is a hybrid orbital, we call that. Okay, all has become the equal energy, that is called as hybrid orbitals. And the new one, this is called as hybrid orbitals. Okay, so only orbitals almost of same similar energy belonging to the same atom will undergo hybridization. They should be of the same atom, not the other atom. Okay, same atom orbitals only will undergo hybridization. That is the most important one. And hybridization occurs only for orbitals, not for electrons. Only for orbitals will be hybridized, not for electrons. Okay, not for electrons. Okay, orbitals hybridization is only for that. Okay, and the number of hybrid orbitals produced is equal to the number of pure orbitals that are there. Suppose if you take sp3, means how many pure orbitals are produced here? One s orbital and 3 p orbitals. So totally 4 hybrid orbitals you will be getting. 3 plus 1, 4. Okay, 4 hybrid orbitals are there. And orbitals are involved in pi bond formation, do not undergo or do not form hybrid orbitals. Okay, orbitals which undergo pi bond, they don't involve hybridization. Only sigma bonds are involved in hybridization. Okay, hybridization, orbitals involved in pi bond do not participate in hybridization. That is the most important one. Okay, they do not participate. And hybridized orbitals always possesses lower energy. Okay, lower energy will be there for hybridized orbitals. Lower energy will be there for hybridized orbitals. So these are the major important points. Okay. Sir, why we have the overlap of SPD and again why hybridization? See, hybridization will give the extent of bond formation and more. Okay, what happens means hybrid orbitals will have more efficiency than the ordinary sp orbitals. Why? All these hybrid orbitals are having equal energies. That is the major concept here. And next types of orbitals we will have in detail now. How the hybridization concept and everything. Before going to that, we will have some points regarding the hybridization concept. Once I will revise all the points what we had a discussion of hybridization, so that you can understand clearly now. Hybridization, it was first introduced by Pauling. Who introduced hybridization? Means hybridization was first introduced by Pauling. For what purpose he introduced? For explaining the covalent bonds, equivalent nature of the covalent bonds. Hybridization means what? It is the mixing of atomic orbitals of different shapes and approximate equal energies, so that redistribution of energy occurs. Okay, redistribution of energy occurs to form new orbitals of same shape and same size. These new orbitals are called as hybrid orbitals, and the phenomena is called as hybridization. Okay, and only orbitals of almost similar energy will participate in the bond for undergo hybridization, and hybridization is only of orbitals, not of the electrons, and the number of hybrid orbitals produced is equal to the number of pure orbitals mixed. So these points, if it is a point wise, it will be very useful to you. Okay, hybridization Z. Okay, it was introduced by Pauling to explain equivalent nature of covalent bonds in a molecule. Okay. Next, what is hybridization means? It is the mixing of atomic orbitals of different shapes and approximate equal energies so that a redistribution of energy occurs, to form new orbitals of same shape and same energy, and same energy. These new orbitals are called hybrid orbitals, and the phenomena is called hybridization. Okay, so this is all about the hybridization concept. The next points what we have is only orbitals of almost similar energy. Only orbitals of almost similar energies and belonging to the same element same atom or ion undergoes hybridization. And hybridization is only of orbitals but not of electrons. Hybridization occurs for orbitals, not electrons. Okay, hybridization occurs only for orbitals, but it is not for electrons. That is the one more concept what we have. Next, the number of hybrid orbitals produced. The number of hybrid orbitals produced is equal to the number of pure orbitals mixed during hybridization. Suppose four hybrid orbitals are produced by mixing of 1s and 3p, that is px, py and pz, pure orbitals. Okay, so this is all about the hybridization definition and the main points. Hope you have noted the definition, so that there are some more points. What are those orbitals involved in pi bond formation do not participate in hybridization, and hybrid orbitals possesses only lower energy. So these points we will be writing, and then we will enter into the types of hybridization. Hybridization definition only I am saying. Hope you noted. And the next what we have, that is in the excited state. In the excited state, the number of unpaired electrons must correspond to the oxidation state of central atom. What is oxidation state? We will have the discussion in the next video. Corresponding to the oxidation state of the central atom in the molecule. Orbitals involved in pi bond formation. Do not participate in hybridization. They do not participate in hybridization. Next, hybridization never takes place in isolated atoms. Okay, hybridization never takes place in an isolated atom, but it occurs in bonded atoms. But it occurs only at the time of bond formation. That too covalent bond only. Next, hybridized orbitals provide more efficient overlapping than overlapping by pure SPD orbitals. And the last point of hybridization orbitals is hybridized orbitals possesses low energy. Hybridized orbitals possesses lower energy. So this is all about the introduction of hybridization. Next we will be having types of hybridization, and I will be giving you a shortcut how to calculate, how to know that a particular atom will have or a particular molecule have this type of hybridization. So types of hybridization. So that we will be discussing now. Okay, now we will be discussing about the types of hybridization. Types of hybridization. Okay, so generally, what are the types of hybridization? Means sp hybridization, sp2 hybridization, sp3 hybridization, and next is sp3d hybridization, sp3d2 hybridization, and sp3d3 hybridization. Okay, so these are the types of hybridization. Okay, so we have types of hybridization: sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, sp3d2 hybridization, and sp3d3 hybridization. So what is sp hybridization? Means the hybrid orbital formations are two sp hybrid orbitals are formed. One s and one p hybrid orbital is formed. 1 plus 1, 2 sp hybrid orbitals are formed. Here 3 sp2 hybrid orbitals are formed. 1 s and 2 p orbitals are overlapped. And in this one s and 3 p orbitals are overlapping. 4 sp3 hybrid orbitals are formed. Like that, here 5. Here 6, here 7. So these are the hybridizations. Okay. So what is the hybridization? We had now the clear understanding. I hope you have got the exact understanding of hybridization. See, I am writing the definition of this. When one S and one P, okay, when one S and one P okay, when one S and one P orbitals, okay, that formed, then we will be getting what? sp, sp2, sp3 and sp3d and everything. Okay, one s and one p orbital belonging to the same main shell. When one s and one p orbital belonging to the same main shell, belonging to the same main shell, okay, belonging to the same main shell of an atom mixed together to form two new equivalent orbitals, the type of hybridization is sp hybridization. Okay, sp hybridization. So this is the definition of sp hybridization. What is sp2? When one s and one p orbital belonging to the same shell of an atom mixed together to form a new equivalent orbital, the type of hybridization is called as sp2 hybridization. And what is sp3 hybridization? When one s and 3p orbital belonging to the same main shell, okay, to the same main shell of an atom mixed together to form how many now? 4 new equivalent orbitals. The type of hybridization is what? sp3 hybridization. Like that, sp3d hybridization, sp3d2 hybridization, and sp3d3 hybridization. How many hybrid orbitals you are getting means here 2, 1 plus 1, 2. Here totally 3. Here 4. Here 5. Here 6. Here 7. So that is the way you will be writing. Okay. Next, what are the shapes of the things? Before going to have that, we will calculate how many hybrid orbitals are present. Okay. Number of orbitals involved in hybridization. If you know this, then you can write which type of hybridization it is. Is it or not? So what is the formula for this is half into V plus M minus C plus A. This is the formula. What is the formula for number of orbitals involved in hybridization is half into V plus M minus C plus A. What is V? V means what? Number of electrons in the valency shell of central atom. V represents number of electrons present in valency shell of central atom. And what is M? M means number of monovalent atoms. Number of monovalent atoms. And what is C? Charge on cation. Okay, charge on cation. And what is A? Charge on anion. Suppose if you want to calculate how many hybrid orbitals are there, means this is the formula. Okay, half into V plus M minus C plus A. You should know what is the central atom and you should know its valency, and at the same time you should know if any cation or anions are there, their charges also. Suppose If I ask you what is the hybridization involved in NH3 or number of hybrid orbitals in NH3 means what I can write like this from the formula. Number of orbitals involved is equal to half into valency. What is the central atom in this? Nitrogen. So nitrogen valency is how much? Nitrogen valency. So we have to see nitrogen 7, 1s2, 2s2, 2p3. So 2, 5. So 5 is the valency. So valency electrons, number of electrons present are 5 only now. So these are the participating one. Okay. Totally 5 electrons are there in the valency shell of nitrogen. Plus monovalent atoms. How many monovalent atoms are there? Means hydrogens here. Monovalent is hydrogen. H per no. So 3. And any cations? No. Anions? No. So 0. So it is -0 plus 0. So total how many? Half into 8. Half into 8 means what? 4. 4, how it is possible? 4 hybrid orbitals are formation is taking place. 4 when you get sp3 only, no. One sp and one s orbital and one p orbital. Then only you will get sp3. Okay. So that is the case. So sp3 hybridization is possible with what? Ammonia. This is the way we will be calculating. So number of hybrid orbitals involved in hybridization is given by what formula? Half into V plus M minus C plus A. V is nothing but what? The number of electrons present in the valency shell of the central atom. Means first you should know what is the central atom. In ammonia, nitrogen is the central atom. So I have calculated its hybridization. If I know the hybrid orbitals, total 4 means sp3 only no, 3 plus 1, 4 only no. So that is the case we have. Okay. sp3 hybridization we call it. Okay. Now regarding the shape and angles we will see now. What are the shape and angles of all these? And then we will stop our discussion. So sp hybridization shape is a diagonal shape. It undergoes diagonal shape. Okay, it undergoes diagonal shape. And the diagonal means what? Axis. So the angle will be 180 degrees. Okay, sp hybridization angle is 180 degrees. And in sp2 the shape is trigonal shape. It is trigonal shape and the angle is 120 degrees. And sp3 it is tetrahedral shape. The shape of the molecule which undergoes sp3 is tetrahedral and its angle will be 109 degrees 28 minutes. And sp3d hybridization, the one which undergoes sp3d hybridization is trigonal bipyramidal shape. It is trigonal bipyramidal shape. And what will be the angle means it is approximately trigonal and bipyramidal, both are there. So it will have two angles. Trigonal means 120 degrees, pyramidal means 90 degrees. So it consists of two angles. 120 degrees angle will be there and at the same time 90 degrees angle will be also there. Next, octahedral. Octahedral means what? All are at closed shapes. Okay, like octagon, octahedral. And sp3d3 is pentagonal bipyramidal. Okay, pentagonal bipyramidal shape. So these are the shapes of the things, and angles are not required for octahedral and pentagonal bipyramidal. For us in any competitive exam they are not asking, only up to this area we have and we are stressing on that only. Okay, types of hybridization. See, hybridization orbitals are these: sp hybridization, sp2 hybridization, sp3 hybridization, sp3d hybridization, sp3d2 hybridization, and sp3d3 hybridization. And how to calculate which type of hybridization does it has means number of orbitals involved in hybridization is equal to half into v plus m minus c plus a. When you know this formula, then you can calculate the number of hybrid orbitals. Suppose if you are getting 4 means it is sp3. If you are getting 3 means it is sp2. If it is 2 means sp. Like that we will be calculating the hybridization and the number of hybrid orbitals. And these are the shapes: diagonal, trigonal, tetrahedral, trigonal, bipyramidal, octahedral, and pentagonal, bipyramidal. These are the shapes. And these are the angles, different types of angles. Okay, hope you have understood. If you have any doubt, you can WhatsApp me. And in the next video we will be having the discussion about the examples of the compounds which undergo sp hybridization, sp2 hybridization, sp3 and sp3d, that all we can see. Now only you need that. You made that, we will give the examples now itself. Okay, so that we will finish this topic. Okay, right. Okay, one by one examples also we will see. sp hybridization. Okay, examples of the molecules which undergo sp hybridization are C2H2, BeCl2, and CO2, CS2, NO2 plus, and HgCl. So these are the examples of the sp hybridization. And sp2 hybridization, the molecules which undergo sp2 hybridization examples are CO3 2 minus, okay, BeF3 minus, and C2H4 AlCl3, BX3 means any compound it may be, and C6H6 and SnCl3. These are the one which undergoes sp2 hybridization. Next, sp3 hybridization. The compounds which undergo sp3 hybridization, that is our water molecule, ammonia, okay, and sulfate ion, and BF4 minus, and methane, OF2, and Cl2O. Okay, so these are the one which undergoes sp3 hybridization. Next, sp3d hybridization. Okay, the compounds which undergo sp3d hybridization. Example, what we have is PCl5. PCl5 will undergo sp3d hybridization. And the compound which undergoes sp3d2 hybridization, SF6. It is the compound which undergoes sp3d2 hybridization, and sp3d 3 hybridization. Hybridization example is IF7. Okay, so these are the compounds or the molecules which undergo different types of hybridization examples. So there may be some more examples, but these are the standard examples of sp3d, sp3d2 and sp3b3. Okay. Hope you have understood, and with this we will stop our total hybridization concept. So in this video you have got the information regarding the hybridization, how to calculate how many hybrid orbitals are there, and how to calculate also we have seen. If you have still any more doubts, you can ask me, and you have to frame your own techniques. Okay. Now, what is the angle in C2H2? Directly you can say how much it is C2H2. It is sp hybridization. In sp hybridization, we have 180 degrees of angle. Like that, you can have directly.